There is a direction that no map of the solar system ever shows with clarity. It is not north, not south, not toward the galactic center, nor toward its opposite extreme. It is something perpendicular to all of that, a direction pointing straight out of the Milky Way's disk. Imagine standing on an enormous table and looking directly up at the ceiling, then down at the floor. That direction exists. It has content, it has structure, and what lies above and below the sun is one of the most underrated stories in all of modern astronomy. And the first thing you need to understand about this story is that the sun is not where you probably think it is. The Milky Way is a barred spiral galaxy, approximately 100,000 light-years in diameter. The sun orbits the galactic center at a distance of roughly 26,000 light-years, nestled within a structure known as the Orion Arm, a minor spiral arm tucked between two larger, more massive ones. But the sun does not sit precisely at the midpoint of the galactic disk, the median plane, where the density of matter reaches its peak. It is slightly displaced above that plane. Available measurements place it somewhere between 56 and 93 light-years above what astronomers call the galactic midplane. To grasp that scale, consider this: the distance between Earth and the Sun is 8 light-minutes. The Sun's displacement above the galactic plane is approximately 7,000 times greater than that. And yet, compared to the total thickness of the galactic disk, the Sun is only slightly off-center, like a musical note placed just above the balance line of a staff. Within a score, thousands of lines tall, the Milky Way's disk is built in distinct layers. The innermost is what astronomers call the thin disk, the region where most young stars, molecular gas clouds, and active star-forming regions are concentrated. This thin disk measures between 1,000 and 2,000 light-years in thickness, and it is within this layer that we live. Surrounding the thin disk lies a thick disk, older, more diffuse, composed predominantly of second- and third-generation stars, with far lower concentrations of gas and dust, extending an additional 3,000 to 5,000 light-years beyond. Above and below this layered disk system begins a territory of an entirely different nature, less dense, more ancient, blazing hot in certain regions, and vastly larger than the disk itself. This territory has a name, the galactic halo, and it is within the halo, and in structures that reach even beyond it, that the answer to our central question begins to take concrete shape. What makes this question so fascinating? Now is that the very concepts of above and below require a reference point to exist. In interstellar space, that reference is the rotational plane of the galaxy itself. All the matter in the disk orbits the galactic core within that plane. And anything perpendicular to that rotation is by definition above or below. The Sun completes one full orbit around the galactic center in approximately 225 million years, a span of time so immense that since the non-avian dinosaurs vanished from Earth, the Sun has traveled only 1/3 of that journey. But the Sun does not move only within the plane. It oscillates up and down along its orbit, crossing the galactic midplane periodically in a cycle of roughly 64 million years. Right now, the Sun is in its ascending phase, drifting slowly above the midplane, moving toward the northern side of the galactic disk. This means the territory immediately above the Sun is, by definition, different from the territory immediately below. Not radically different on a galactic scale. Both sides of the disk are roughly symmetrical in their overall distribution of matter. But there are specific structures, singular phenomena, and distinct astronomical histories in each direction, making every side genuinely unlike the other. Uncovering them demands crossing the galactic disk in both directions, peering beyond the visible stars, beyond the luminous gas, beyond anything a naked eye could ever reach on the darkest of nights. What you will find up there will change the way you understand the space that Earth calls home. And what lies below is even more unexpected. Rising above the galactic disk is like breaking through the surface of a dense ocean. Below you, the disk's density, its gas, its dust, its forming stars and vivid nebulae grows ever more distant, ever more faint. Above you, space opens in a way that defies every intuition built from gazing at the night sky here on Earth. And one of the first structures you would encounter on that ascent, departing from the Sun, in a straight line perpendicular to the galactic disk, would be something humanity only discovered in 2010, something that forever changed the way science understands the energetic history of our galaxy. In November of 2010, data from the Fermi Space Telescope revealed two colossal structures erupting from the core of the Milky Way, one reaching north, the other south of the galactic disk, twin lobes of gamma-ray emission, stretching roughly 25,000 light-years in each direction from the galactic center. These structures became known as the Fermi bubbles. To grasp their scale, if you could see the Fermi bubbles with the naked eye, they would span a greater area of the sky than the entire constellation of Orion, despite being tens of thousands of light-years away. And they are not empty structures. They are regions of superheated plasma and ultra-high energy particles, radiating at wavelengths the human eye cannot detect, yet which telescopes reveal as brilliant, nearly perfectly symmetrical lobes above and below the galactic plane, like two lungs swollen with energy rising from the very heart of the galaxy. The origin of the Fermi bubbles remains the subject of active scientific investigation. The most widely supported hypothesis is that they were forged during a period of intense activity at the galactic core, possibly a phase in which the supermassive black hole at the center of the Milky Way, known as Sagittarius A, was consuming matter at rates far greater than anything observed today. All that energy, unleashed in particle jets and plasma winds, drove galactic material outward from the disk, inflating these bubbles over millions of years in a process of truly colossal scale. It is the cosmic equivalent of two invisible balloons being inflated simultaneously above and below the center of a galaxy, with the difference that each of those balloons stands roughly as tall as the total diameter of the visible galactic disk. And in 2020, observations from the Rosetta Space Telescope revealed that the Fermi bubbles are themselves enveloped by even larger structures, the Rosetta bubbles, visible in X-rays, stretching some 45,000 light-years in each direction from the galactic core. These outer bubbles are older and more diffuse than the inner Fermi bubbles, most likely the remnants of an even earlier episode of explosive activity at the galactic core, or perhaps of multiple such episodes accumulated across vast stretches of time. The Milky Way, which from the outside appears to be a relatively calm disk spinning through space, is in reality wrapped in structures of plasma carrying billions of years of history, stretching across distances comparable to the galaxy's own size, invisible to the naked eye, yet absolutely present and measurable. But the Fermi and Rosetta bubbles are not the only structures inhabiting the space above the disk. Scattered across the vast expanse of the galactic halo, which extends more than 100,000 light-years in every direction from the galactic core, there exist approximately 160 known globular clusters, each containing between tens of thousands and several million stars packed into a relatively compact sphere. These clusters are the oldest stellar structures in the galaxy. Many are over 12 billion years old, meaning they formed when the universe itself was barely 1 to 2 billion years into its existence. To gaze upon a globular cluster in the halo above the galactic plane is to look upon stellar fossils, survivors of an era when the Milky Way was still being assembled through the merging and absorption of smaller galaxies. Each cluster carries within it the chemical and dynamical memory of a younger universe. The galactic halo itself, beyond these visible structures, is filled with a hot and diffuse gas, plasma, heated to temperatures on the order of hundreds of thousands of degrees. And permeating it all is a dominant quantity of dark matter, that invisible substance accounting for the vast majority of the galaxy's total mass. The Milky Way's dark matter halo extends hundreds of thousands of light-years beyond the visible disk. Without it, the galaxy would lack sufficient gravity to hold its shape or sustain its rotation. It is completely invisible. It emits no light at any wavelength current telescopes can directly detect, yet it is absolutely fundamental to the existence of everything. It surrounds the sun from every direction, including from above. What lies above the sun, therefore, is not emptiness. It is an architecture of plasma, energy, ancient stars, and invisible matter that makes the galactic disk, with all its richness, appear as little more than a thin layer within something far greater. To rise above the galactic disk is to encounter colossal plasma bubbles and star clusters carrying billions of years of history. To descend below the galactic midplane opens an entirely different perspective and leads directly to two of the most extraordinary structures the Milky Way possesses. Two satellite galaxies visible to the naked eye, companions to our galaxy for billions of years, which even now are being slowly drawn inward and absorbed in a process of merging that will outlast the entire history of complex life on Earth. The Large Magellanic Cloud and the Small Magellanic Cloud are the closest galaxies to the Milky Way visible without a telescope. The Large Magellanic Cloud lies approximately 160,000 light-years away. The Small Magellanic Cloud sits at roughly 200,000 light-years. Both are positioned below the galactic plane of the Milky Way, inhabiting the southern side of the galactic halo, the same territory the Sun would occupy if its perpendicular oscillation through the disk carried it in the opposite direction from its current path. For those who live in the southern hemisphere, like the inhabitants of Brazil, both galaxies are visible on clear nights as milky smudges suspended in the sky. Fragments of another galaxy, reachable by the naked eye alone, without instruments, without any technological mediation. It is one of the most extraordinary experiences available to anyone who simply looks up on a clear, dark night. Far from the lights of the city, the Large Magellanic Cloud is no small galaxy. It contains between 10 and 30 billion stars. It boasts one of the highest rates of star formation of any galaxy in the local group, the collection of galaxies to which the Milky Way belongs. And it harbors the Tarantula Nebula, a star-forming region of such extraordinary intensity that if it were placed at the same distance from Earth as Bond, the Orion Nebula, it would cast visible shadows on the ground at night. The Large Magellanic Cloud is an irregular galaxy, likely warped by the tidal forces of the Milky Way across billions of years of gravitational interaction, and it is closing in on a trajectory that will inevitably end in merger. Estimates suggest the most intense approach will occur in approximately 2.4 billion years. This merger will dramatically reshape the structure of the Milky Way, adding mass to the disk, igniting new waves of star formation, and likely disturbing the galactic core in ways we are only beginning to model. Between the Magellanic Clouds and the Milky Way lies a structure that is itself a subject of intense research, the Magellanic Stream. This structure is a filament of neutral hydrogen gas, stretching across roughly 100 degrees of sky as seen from Earth, the equivalent of 50 full moons placed side by side in sequence. The Magellanic Stream is gas that was stripped from the Magellanic Clouds by the gravity of the Milky Way over billions of years of interaction, leaving a trail of material along the orbit of these satellite galaxies. It is like witnessing the trail left by two objects orbiting a far greater mass, except that these objects hold tens of billions of stars each, and the trail stretches hundreds of thousands of light-years in length. Some of that gas is slowly falling toward the disk of the Milky Way, where it will eventually fuel new generations of stars, matter, drawn from another galaxy, destined to become the raw material of future solar systems within our very own galaxy. Below the galactic disk, the halo shares the same general characteristics. To the north diffuse hot gas, ancient globular clusters, a hidden scaffolding of dark matter. But the presence of the Magellanic Clouds and their trailing stream of gas makes the southern hemisphere of the galactic halo a far more dynamic environment, one of active gravitational interactions and real-time flows of material passing between galaxies. Several smaller satellite galaxies also orbit the Milky Way below the galactic plane. Structures, known as dwarf spheroidal galaxies, such as the Sculptor and Fornax galaxies, whose dark matter content vastly exceeds what their visible starlight alone would suggest. They are natural laboratories for the study of dark matter, existing in silence below the plane of our galaxy, invisible to the naked eye, yet present and measurable to modern instruments. What lies below the Sun, therefore, is not emptiness, it is an ecosystem. A complete galactic ecosystem, streams of intergalactic gas, and a halo of invisible matter anchoring it all in place, as the gravity of the Milky Way slowly draws these billion-year companions toward the greatest merger in our cosmic neighborhood. Yet there is one detail about the Sun's current position that almost never surfaces in any discussion of astronomy, Minra. But that makes everything you have just learned about what lies above and below genuinely personal. The Sun is now on the northern side of the galactic disk, above the galactic midplane, moving upward, slowly drifting away from the center of the disk in its perpetual perpendicular oscillation. This means that as you read these words, as the Earth completes its daily rotation, as the solar system presses forward on its 225 million-year journey around the galactic center, you are on the northern side of the Milky Way's disk. The Fermi bubbles, the Aeroiceta bubbles, the globular clusters of the northern halo, carrying within them billions of years of history. All of it lies above you, right now. The Magellanic Clouds, the Magellanic Stream, and the dynamic southern halo lie below. This is not an abstraction. This is the true geometry of your position in the cosmos at this very moment. But that position is temporary, as all positions in the universe ultimately are. Universe. The Sun does not oscillate indefinitely in one direction. At some point in the next few million years, it will reach the highest point of its current oscillation, slow down, and begin descending once more toward the galactic midplane. It will cross that plane, passing through the densest region of the disk, where the gas clouds are thickest and gravitational disturbances most frequent, then emerge on the other side into the southern hemisphere of the galactic halo. This crossing occurs in cycles of approximately 32 million years from one side to the other, and across the entire history of the solar system, the Sun has already completed dozens of these cycles, crossing the galactic disk repeatedly, like a pendulum swinging through a haze of stars and interstellar gas. Some scientific hypotheses suggest that these oscillation cycles may have influenced the solar system's environment across geological time. As it crosses the galactic plane, the Sun passes through regions of higher gas density and giant molecular clouds, and the gravitational disturbances from these structures may destabilize objects at the outer edge of the solar system, in the region known as the Oort cloud. This hypothesis remains a subject of scientific debate and has not yet been established as a definitive conclusion, but it illustrates something that reaches far beyond the hypothesis itself. The Sun's position within the galactic disk, whether above, below, or within the plane, is not a purely geometric question. It is a question with real physical consequences for the environment in which Earth has existed across deep time. What makes all of this so extraordinary is that the question of what lies above and below the sun seems at first glance like a geometric curiosity with no practical consequences. But the answer reveals something far more profound. The sun is a dynamic object within a dynamic environment, moving in 3 dimensions through a space filled with structure, history, and active processes. Above lies a halo of fossil stars and superheated plasma, colossal bubbles sculpted by explosions from the galactic core across millions of years, and the invisible tracery of dark matter that holds the galaxy together. Below lie 2 satellite galaxies locked in slow gravitational merger, a stream of intergalactic gas stretching hundreds of thousands of light-years, and dark matter-rich dwarf galaxies orbiting in silence. Neither side is empty, neither side is static, and you, at this very moment, are floating just slightly above the midpoint of all that architecture. That brings us to a question we would love for you to answer in the comments. If you could choose to travel instantly in a straight line, perpendicular to the galactic disk, which direction would you choose? Upward, toward the Fermi bubbles and the globular clusters carrying 12 billion years of history, or downward, toward the Magellanic Clouds and the Magellanic Stream of the southern halo? Write it in the comments, because that choice reveals something genuine about how you see the universe. The next time you look up at the night sky from anywhere in Brazil on any clear and dark night, what you are seeing is the surface of the disk, the thinnest layer of a structure far thicker, far richer, and far more alive than that band of visible stars could ever suggest. Below that sky, beyond the southern horizon, the Magellanic Clouds exist right now, being slowly drawn toward our galaxy in a dance that will last billions of years. Above, invisible to the naked eye, but absolutely real, the Fermi bubbles stretch across 25,000 light-years, like the echo of a galactic explosion that erupted long before any human being ever existed. The universe is not a stage where Earth stands motionless at the center. It is an environment in motion, in every direction, including the ones no map ever bothers to show. If this documentary changed the way you see the space that Earth inhabits, subscribe now so you don't miss what comes next, because each one explores a different dimension of the cosmos with the same precision you witnessed here. And if you know someone who still believes that empty space begins just above the clouds, share this video with them, because after this, they will never look at the sky the same way again.